Hello, everybody. Welcome back. ConTech Exec here with Todd Zabelle. This is part 2 of our series. We're going to do a couple more of these, but today we're going to jump into what Todd wants like to call you. This is going to be a lightning round, and I think we're going to get a lot of information in here today, so you want to stick around for all of it. First thing I want to do is I want to kind of correct myself from our last podcast he and I did. I had flow kind of all wrong, and I want to correct myself and say I'm sorry. I didn't mean to like screw anybody's idea of what flow was up, and hopefully you guys understood what it was. We're probably going to talk a little bit more about it today with Todd, but we're going to jump right into this lightning round. Todd, thanks for being here today. I know you just jumped off a plane not too long ago, so I really do appreciate your time. Thank you so much.
Thanks for having us again, Robert. Really looking forward to it. And I think the idea of a lightning round rather could be very interesting and see how well we do. Right. So let's have some fun.
Right. Yeah. Let's see how much lightning we got in the bottle here.
Right.
Okay. Let's find out. Okay. So lightning round question number 1. We're going to be talking about projects are mini factories. Projects are factories. So question is, why don't we manage them like production systems?
Yeah, I think there's a couple things there, and that's a excellent question. Number one, I believe when we attempt to explain to people that projects are a form of production, and let's leave it at that for a sec, anything that we use in a term of production, manufacturing, or any terminology that's not construction or project specific, we get immediate pushback saying that's not us. Now, interestingly enough, when you talk with manufacturing guys, they'll say we're not construction. So clearly, and I've been doing a lot of thinking about this lately, there's this idea of a tribe. What tribe am I part of? And if you're not one of us, I don't really want to hear what you have to say. So I will say that's number one. But what's interesting in all this to me, and maybe we could put a little bit more color on this, almost everything humans do is production. We take inputs and we make outputs. We take in food, something comes out. We take in water, something comes out. Synthesis of plants, everything is related to production starting in nature. A lot of production guys go off into that world in nature. So construction is clearly a form of production. There are standards, methods, science, as we know, we're talking here, is what this is about, where we could better understand and influence how production occurs. That is the field of industrial engineering or of production industry. Now, why is that not popular in the construction industry? I think that's a really interesting question, and it probably gets back to a lot of what we do in construction today, rooted in what we call Era 1, the Taylorism type stuff is rooted in production. People involved in mechanical engineering clearly understand production, but when you get into architecture and structural engineering, especially structural engineering and civil engineering, they deal with static things. And I had a civil engineer tell me this last week when I was in London. He said, look, I'm a water engineer and I understand this mechanically, but I work with a bunch of structural engineers that live in a static world, right? So I think there's a lot of factors that come in and we bend people's thinking when we propose that construction is comprised or is a form of production, and that any kind of production we can understand and improve.
Okay. That all makes sense to me. To think, okay, look, there's elements of production in everything that you do in construction. I get that. Then that leads us to this next part, kind of part 2, activity versus flow. So why does maximizing trade utilization kind of hurt overall performance?
And I'll add to that, why do we do that? So let me just come back, because I hinted to that with Taylor. Frederick Taylor, and the turn of the beginning of the last century, rather, was a mechanical engineer. Kind of was the first industrial engineer guys as we can know it today. And he believed if everybody in a chain or in a process worked as fast as they could or as hard as they could, you'd get more out. And that's completely logical, right? Now, one of the things that the Lean Construction Institute we worked on very early on in the early days was this idea of dependence, and we called it variation back then, but probably variability is a better word. If we're dependent, okay, I do something and then you do something, and if I do it at a different rate than you do it, like we talked in the last podcast, then either one of us is going to be waiting on the other one or something's going to build up between us. When you look at the end-to-end process and you have that dependence and variability, it's the cues that build up in between that extend the duration, right? Taylor missed that. Now, when we moved from what I would call era one, Taylorism or scientific management, the whole concept of productivity, to era two, where we were focused on predictability, we didn't go back and address that. We actually, maybe the word is, we celebrated that by saying we're going to go do things like studies time on tools, productivity, and the rest. And we didn't look at it from an end-to-end perspective. We looked at it from an individual step of the process. And that's really what Toyota figured out working with American companies, or American consultants rather. They went back and studied what Ford was doing. And Ford was all about, I know you want to get into flow at some point. The flow through the total value chain is what Ford understood and Toyota adopted, where others went a different direction. And we could at some point talk about why that occurred even.
It's funny you mentioned the kind of the studies, I think it was the studies of the human, measuring that human input. My dad, I actually have a book down here. It's an old textbook of one of those studies from way back when they, human movement from one process to the next, kind of that factory ideas. If you move 3 steps this way, why are you doing that? Why don't you just move the table a little closer? Those kind of things. So totally makes sense to me. So yeah, let's get into this, because you did mention variability. So variability is the real killer, right? So how do trade handoffs and uneven work rates destroy that throughput? How does that work?
Right. We touched on that. So I think the big idea we got to get across, and let's see if we can make this as simple as we possibly can. If we have a series of operations being performed in a connected process, okay, we know we can only go as fast as the bottleneck, right? And so the bottleneck will tell us how much we can get through the system. It doesn't matter how much we push in or how much capacity we put after the bottleneck. We're only getting through what's known as the bottleneck rate, okay? Now, the variability comes in when we have differing production rates amongst each station, all right? Again, if I'm handing off to you and I'm going faster than you, a queue is going to build up in between us. If I'm going slower than you, you're going to be standing around waiting. Okay. That goes through the complete production process. But at the end of the day, where we need to focus is the bottleneck. Now, you mentioned the book that your dad had, which is basically those are techniques that we want to apply to the bottleneck to address that issue to increase throughput. So we're not saying that doing that kind of work isn't necessarily good. What we're saying is we want to concentrate that on the bottleneck. And then as we begin to improve the bottleneck, we also want to be cognizant of where we may be spending resources, either buildup of WIP or unnecessary capacity standing around that we don't need, right? But the idea of variability, people get confused. They think it's uncertainty or they think it's late deliveries. And sure, late deliveries can cause variability, right? The other thing that's really important to understand is variability could be good or it could be bad. And it depends on what perspective you have, right? So beneficial variability would be a late change in design that the business case can absorb that and makes it better, right? So a new technology comes out and says, we better adopt to the new technology or we're out of business. That's huge variability in the project, but that's beneficial. Detrimental variability is the stuff we're talking about where you have dependence going on in different work rates, all right? And that's why I keep coming back to work in process, not progress, but in process. The WIP buildup between you and I, or the negative WIP, if you will, that tells us what's happening very quickly and visually between our relationship. If I'm working faster than you or slower than you.
Okay, so you're jumping into my my lightning round question here with that work in process versus
Okay.
work in progress, which I totally appreciate, because it's kind of but I think we need to define that. It's from my understanding. Okay, work in process versus work in progress. People put WIP on something and it means 2 different things, from what I'm understanding to you or from you.
Yeah, and so let's do this. Let's add. I'm sorry to keep doing this to you, but let's start off with the concept of inventory. And there are basically 3 types of inventory. And again, this has to do with the perspective where you are in the hierarchy, I guess, between the owner to, let's say, the CM down to the specialty contractor, right? And so let's start down at maybe the production level where the specialty guy is, right? The specialty guy has, whether we're on site or in the fab shop or even in design, there's inbound stuff. Okay. And let's just set design aside for a sec. So I don't get too far out there. Inbound raw materials, steel, right? Aluminum, coil, whatever the case may be, aggregate, whatever we have. So there's inbound materials. And then we have what we might call finished goods, things that are either rather in the shop ready to ship to the site, or they're things at the site waiting for the next trade, right? So we got two types of inventory: inbound raw materials and finished goods, finished work. Okay. Anything in between at the shop is work in process. So we've taken some raw materials, we've cut them, maybe we're drilling them, we're grinding them, we're polishing them, whatever our process is, that's the WIP. If we extrapolate up a level, and let's say we get up to the owner, everything going on in a project from the moment you launch the project till the time you hand it off and put it in operation is WIP, work in process. Okay. The key with work in process is if we want to measure how long something is going to take or predict, we do that by measuring the WIP. The WIP is the proxy for time. Okay. Now, is that good so far?
That's great. I'm following.
Okay. All right. Now, work in progress is really the financial measurement of those physical things. So in production, we would say we got 20 widgets in inbound materials. We've got 40 widgets underway, and we got 30 done. All of that would be our inventory with our inbound, right, and so on and so forth. So what has happened, and this is another tangent someday, and maybe the third one we talk about, this idea of percent complete accounting, rather than count the widgets, right, wants to use economic measurements to figure out where are we, right? So I think the key thing with work in progress is to question, how did we calculate the work in progress? If we're using percent complete accounting and we say it's going to cost $100, we spend 80, we're 80% done, right?
It's not
That's
necessarily
far
true.
different than counting the widgets. And that's one of the concerns I have, that I've been on kind of a crusade lately, is this idea that we're counting on financial measurements of dollars spent compared to budget to figure out where we are, rather than in production terms, we can count the widgets, if that makes sense.
And that's where the big disconnect happens, right? Financial guys over there going, we've spent X amount of dollars, we should be X amount done, right? That's not necessarily the case. Same thing happens at that specialty contract level, even down to the superintendent level, where somebody is given a budget of hours and materials, and it is crafted in, say, dollars. Let's say you have a $500 budget to do whatever. Well, what he does is he says, I got two guys that worked a few hours here, a few hours there, and they did use this material. And he writes it all down as dollars and cents, hours on the budget. And it says, oh, hey, by the way, I've got, of my 50 hours that I'm supposed to put in, I've already put in 25. I must be 50% done. And so they write down $250. Well, not necessarily, right? Because they could be just what we call pencil whipping those numbers so that they look good. Because they could have some hours left over from something else. Maybe they shuffled some dollars over here or shuffled some hours over there. And then it becomes a big mess because it's not truly a measure of what is really done, what's in place, basically. So I get it.
Yeah, I have no idea. And again, I used to be a specialty contractor. I have no idea why you'd give craft guys any kind of budget for anything. I'd rather spend my time and figure out how can we make the process get more throughput if we want to get more throughput, right? I just don't know why you give them that. What do you want them to do with that information, right? And if you look at how involved they not are in the design of what they're doing, right? They probably didn't select the materials that begin to dictate the means and methods to when the stuff got delivered, who got hired to do the work. At the end of the day, there's very little that these guys control. And I just don't know why you give them that budget, what you want them to do with it. And then if you whip them with that thing, they start playing all sorts of games and the rest. I just don't understand it. I mean, it's incompetent management to give a foreman or a superintendent a budget and tell them to go do something with it. It's just not, they should be focused on production. And if you focus on production, you actually will probably beat your budget significantly.
Yeah, totally agree with that. I see it a lot with certain folks, and it seemed to have been something that was, and I don't know when that all got started. And it may be kind of, I don't know, maybe it was, I don't know. Did it come from CPM? Do we think it came from that critical path management? Like, when did all this kind of start? So, like, we know the CPM isn't production control, but it obviously somehow did something well, but it's trying to do something it's not designed to do.
Well, CPM is an interesting thing, and a lot of people don't understand this, but I'll give you a couple things. All the CPM is the longest, the set of longest durations through the project. Okay. And when you look at it from a production perspective, we consider everything to be critical, right? Because we're focused on a different thing. CPM is focused on dates. We're focused on rates. Okay. So if you want to figure out the dates, you got to calculate the rates. So if you say, I got to put in, I don't know, 100 piles, then someone figures out, I would hope, it takes a day a pile or 2 days a pile. So it's going to be 50 to 100 days, right? So you start with rates and then you put it in dates and then you got to bring it. And as soon as the guy, every specialty contractor understands tact, okay? And that's pretty simple. I got X amount of time to do it and I got to do 100. Okay. So the schedule says I got 100 days, I got to do 100. And then I'm going to say, do I like 100 days? Then I'll just go down the road 100 days. Is there value in me trying to get it to 50? I'm going to walk in there and say, okay, guys, I could do it in 50. And then I'm going to try to figure out, should I start later or start sooner, right? So this whole idea of the critical path and the value of it, I don't fully understand. The idea that you're going to work in dates versus rates is a fallacy, okay? And if you go back, and John Fondel, who many consider to be the father of CPM, right? So this is the guy that worked at Stanford when Kelly and Walker came out with the paper on critical path. I think it was in 1959 or something. Don't quote me on that.
I think you're
On
close.
CPM,
Yeah, I think that's close. Yeah.
it was Remington ran Univac that was trying to sell computers. They developed this thing. Davey Dox went to Fondal and said, "Hey, can you interpret this for a manual system?" Which he did. Stanford did that, and they released it. He comes back at an award ceremony many years later and says, "Look, any schedule that requires what he calls resources would be resource constrained." Okay. And that the schedule will only be as valid as your ability to manage the resources. Right. And that's really what he's talking about is production. So he says that it's kind of, questionable how this whole thing works. Right. Now, remember, he didn't invent CPM. He was asked to translate CPM from computer language into a thing that the Navy would be able to use without having to hire the computer guys. So, I don't know. I don't think most people even know what CPM is. And what they are is they're very enamored with bar charts. They think in bar charts, and that's cool. And that really is Gant, who used to work for Taylor.
Right. Yeah. Well, we're using inventions from 1902 or 1903 to run modern day projects. I don't know. I think there are a lot of folks out there, kind of, especially kind of on the ground folks that understand like the CPM schedule. It really means nothing to them because they're the builders, right? They're building from point A to point B. We know that from point A to point B is going to take X amount of time via, some cycle time that's going to take you to, and from our last conversation, you got 1 million fasteners to put in. How much time does it take you to put in 1 million different fasteners, and what kind of material are you trying? Again, they're thinking about those things. I think when you're looking at a kind of a maybe executive or financial level, which is really has somehow become the driver here of, hey, I need to look at the CPM schedule so I can figure out, when you're going to cash my next check, kind of thing. So I just kind of wondered. I think it becomes this miscommunication. It's kind of like the difference between, the way I see it is your definitions are different. When you say work in progress and say WIP, somebody else says, or work in process, and you say WIP, somebody else says work in progress and they say WIP. It's not the same thing. We have two different definitions. When somebody says CPM, they think they're talking about everything that's included in and maybe lean construction. And it's not. It has nothing to do with it. It may be it may be some fantasy of what you're trying to get complete or what you thought would happen, but it really has nothing to do with how the build needs to go.
Yeah, I'll put a little more color on that. I happened to be out on a project last week, and they were it's a data center project, and they were going to uh, finish off construction and head into commissioning. I said, how do you do that? And he said, well, we've got we, we go on the modules, we put a red sticker on, means one thing, and then a yellow sticker, then a green sticker means it's energized, right? And I said, how do you know what sticker to put? Oh, we got a spreadsheet hanging on the wall, right? And there's a whole stack of people that are what he called tracking. So here we are building a advanced data center, right?
With sticky
Um,
notes?
no, not even, they're putting actual, decal things on or stickers, but yeah, it wasn't even that. And there was just a spreadsheet listing all these things. And I thought it was the most interesting part. I think to go back though, and so that's the reality. Like you say, when you go with the boots on the ground, and we try to do that as much as we can, when you get on the ground, you see the reality of what people are doing. They're talking about CPM and the rest, but let's be clear: the number one scheduling software in the world, the heavyweight champion, is Microsoft Excel. There's no doubt about that. That's how things get done with people tracking. I think this whole thing with the work in progress and the CPM and the rest really comes out of this era two heavy project controls thing, and the project controls people trying to be able to do their job, imposing on foremen and superintendents how they want them to do the work. And if you look at how they when they put these schedules together, a lot of them aren't, and I think that's what you're trying to work towards, is you can't even follow the logic of what they're talking about, right? I mean, it gets to the point where back in the day, it's like, you need to be doing this work. I'm going, but you don't even have the steel erected yet. But that's what the CPM says, right? And so we don't want to go out and actually measure the production that's complete. So we're going to go use a financial calculation. And then that financial calculation became the tail that's wagging the dog by driving the behavior in the field. And then I think these guys said, tell me how you're going to recognize and reward me. I'm going to show you how I'm going to behave, Goldratt's quote. And so these guys go ahead and say, yeah, all right, let's just start playing with the numbers, right? Because I got to get you off my back. I'll tell you a story on a very, very large project in Australia, very, very large project. There was a meeting with the project controls guys and 40 foremen. There's probably 80 guys in the room trying to figure out the fuck was going on, right? And they weren't interested in, did you wreck column 22 or put in beam 38 or whatever big LNG project. They were interested in work package, cost code, whatever. What's the progress? Work package, right? Because they're just trying to do their job. And so I think all this project control stuff can be automated today, and we just need to automate it and just get rid of that stuff and do it as you're proposing, which is counting the actual units. The final thing I'd say is, yeah, we went back, we talked about the fasteners last time you brought that back up. Wouldn't you rather spend the time working with your foremen, superintendents, and craft guys on how to put in the million fasteners faster rather than having them be accountants on the job? These people didn't sign up to be accountants. They didn't go to that. That's not what they want to do. Right.
Yeah. Yeah. No, I think that's a fantastic point, because first of all, we've gotten to a state where we don't get the people that actually build involved in the part that is the plan, right? Because there's maybe would shed too much light on this fantasy of that schedule, right? It would shed way too much light. So and you and I talked about it last time too, that kind of administrative level they're trying to do their job because that's where they've been either trained at whatever school, or that's, the expectation of the executive level to do. This is how you do your job, and this is what we're looking for. We need it done by the said date. I don't care how you get it done. Right. And so everybody's kind of looking at that, again, dates over rates instead of rates over dates. And when you get people that are actually builders that know how to do things, that tends to disappoint these kind of fantasy level schedules that tend to get generated, right? And I'm not saying that there aren't people, in that middle level that don't know what they're doing and kind of get it and understand. There are those, but we deal on most part, and just statistically, capital projects are often known, 98% of the time they don't finish on schedule or on budget. And sometimes both, I guess.
Yeah. So I would say that this scheduling thing you're talking about, it's really interesting. And what I'm hearing out there, again, this is on the front lines in the dirt, if you will, is that, well, a couple things. One, this fallacy that you can manage design with a CPM. We were dealing with that last week. That's just completely bizarre, because that's an iterative process, right? Doing design. I mean, that's not even a concept, but there's guys out there trying that. But I think this CPM measurement thing. It came out, and part of the problem now is basically every owner mandates that you're going to do that. And so
Mm-hmm.
we're involved in an extremely large project in the UK. And I was talking with my buddy, the civil guy, and I'm like, Ed, this is not a UK thing. This is a global thing. So we brought a spec for project controls from another project in another industry, and it was verbatim what they had. I said, this is just a copy and paste that people are out there putting in, and it's a burden on the people that need to do the work to fill the stuff out when these things could be, if we now have the technology to follow production, automate all that,
Right.
right?
It's setting them up a little bit for failure a bit, right?
Well, the system's performing exactly how we expect, right? You're getting exactly what you bought when you do that.
That is right. That is right. So let's talk about this. Let's get back to the kind of the lightning round thing. We kind of touched on, bottlenecks and determining duration. So let's talk about, why does the slowest constraint, kind of set the pace, and not the hardest working crew? I think this is an interesting topic.
Yeah, that's interesting. So in technical operations science, vernacular, if you will, the station, or in this case, let's call it the trade in the process, okay, at the highest level of utilization is the bottleneck. And people get confused about that. So the great thing about uh, production management, especially operations science, is there's very, very defined terms. If you go to PPI here and you go to projectproduction.org, it's all free. You can look in the glossary. But these are terms that have had, what we call it, refereed papers and written about them, and they're in the dictionary, right? So the definition of the bottleneck is the step in the process or the piece of equipment in the process at the highest level of utilization, right? And that's why it can't go any higher necessarily, right? Or maybe go a little bit higher, but it is the point that is setting the pace for things flowing through, because it's at the highest level of utilization, right? And so what we're trying to do is figure out, is that at the level of utilization? So when it comes to bottleneck, we want to know, is it where we want it? Well, is it what we want to be the bottleneck, and is it where we want it? It's kind of the same thing, but right. And we want to use the bottleneck as a governor where we could turn the flow on and off. Again, if you talk to a mechanical engineer, they go, I totally get it, right? As a matter of fact, for the mechanical engineers out there, we've designed a system that almost every process fills a vessel or a tank. Right? We do work, we fill a tank. We do work, we fill a tank. We do work, we fill a tank. This goes back to your concept of flow, rather than having it flow through the systems and figure out where we want to put the tanks. For other people, they don't fully understand that, right? But again, the bottleneck is the station at the highest level of utilization, right? Now, it could have lower utilization, but typically it's pretty high. We've seen in modeling production systems, utilization figures at 300%. You're going, that's not possible. You can't go over 100, right? But it's not well understood. There's also this idea that we should level everybody out and make them all the same. You don't really want to do that, because then you can't control the production system, because you don't know what's happening where, versus if you have a bottleneck and you put the bottleneck of what you want or where you want, then you have a governor to control production. Because there are times where you need to control production. You may have a guy, well, I remember we were involved in a big project, another large project, the rebar guy, he just wanted to go crazy. And what we had to do was drip feed that guy and only allow him to take in a few days of information. Otherwise, if he got more than a week's worth of fabrication input, he'd just keep going, right? Just build up all this WIP. And the problem was, the site was very dynamic. And if there was a change on site or a reroute of the work, that guy was sitting on a bunch of inventory and wasted a bunch of resource. We wanted him to keep a capacity buffer. So we wanted the rebar guy to be at a low level of utilization so he could have quick response. For his business, he wanted to be at a high level of utilization, and he was messing up the flow. It was the work on site that was the critical element, right? Drilling and then dropping these pile cages in and then placing the concrete to make a in situ pile. But this guy, for him, he thought he would be of great assistance by being the highest utilization. But the site couldn't consume, so his high utilization was just building queues that were at risk of some kind of change, right, or obsolescence. Not to mention, you're just sucking out a bunch of cash that didn't need to be sucked out.
You're just kind of in the way when you don't need to be in the way.
Yeah.
Is the way I look at it.
Yeah.
Yeah, I totally understand that. Especially when you start to talk about, construction sites, you got me thinking when you started talking about how everything's kind of working together. It is an engine. It's not you call it a factory, right? But it's an engine, right? Where you have X amount of gas flow that you've got going in, you've got X amount of air that you have going in. You have to, tweak those to get it just right to get that engine to fire. Just in the same way, and your cam has to be hitting at the right lobe, and all those different things, and everything's got to work together in order to make that engine run. And a construction site can be that, but you have to get very, very specific about where those areas are that need to be tweaked and need to be running correctly. What is your control factor?
That's very interesting. So let's take a look at that. And one of the terms that we're hearing a lot about there, and I'm glad that people are talking about this, is systems engineering. Let's talk about a systems perspective. So let's take an engine and look at it from a system. The only thing that you control in an engine system once it starts is the intake, whether it's injectors or carburetors. Okay. Um, and so that's all you're doing is you're controlling how much the flow of fuel's coming in and the air at the same time through either injectors or a carburetor if you still have that technology. Okay. You're not controlling the oil pressure. You're not controlling the water feed. You're not controlling the ignition necessary. Maybe with electronic ignition, it's getting in the play now. Okay. Maybe that's a little bit different, but I'm back in the days where you're putting magnetos in those things. You probably figure out that I have a little bit of a background in this, but you're controlling primarily the intake of the fuel, which is air and whatever the liquid fuel is, gasoline, alcohol, nitro combination. Some guys put laughing gas in or whatever, nitrous, whatever the situation is, and everything else is responding to it. So you're sure you've made a set of degrees on on the lobes on your cam, right? Your crankshaft and your compression are set a certain thing, but that fuel's controlling all that stuff going up and down, right? Literally.
But yeah,
And
yeah,
so,
it's the explosion happening at the right time. Whenever that
right.
pulls together, right?
And you want to get that synchronized. And so I think you're exactly right in what you're saying is if we look at this from a system perspective, how can we get minimal control points that allow us to have maximum influence on the production system, how it's going to behave? And that's the whole world. We could talk about this next time of production control, right?
Yeah.
And so this would be the equivalent to me to go back to the CPM is a CPM advocate would say, I'm going to have a schedule for the crankshaft. I'm going to have a schedule for the camshaft. I'm going to have a schedule for the water pump. I'm going to have a schedule for uh, the ignition. I'm going to have a schedule for the injectors, right? And they're trying to schedule all that stuff. And you're saying at the end of the day, this whole thing is designed as a system. Once we fire it up, all we do is control the intake flow. And maybe today with modern technology, controlling the ignition as well.
Yeah, so that's great. And what's fantastic about that, it leads me right into this next, lightning round question here. Um, let's talk a little bit about, AI. I always say AI, but let's say technology, modern technology here, through a production lens. Does AI fix flow, or to just kind of measure the chaos a little faster? What what elements of kind of this new technology are going to be most impactful, when we start thinking about this?
So going back about, it was pre-COVID, I had the same exact question, right? I was like heavily trying to figure this out. And I happened to be in a technical thing we did at PPI in San Francisco. And in the room were Mark Spearman, Phil Kaminsky, who headed up the IEOR department at Berkeley, and a few other guys at that level. I mean, world-renowned guys that wrote textbooks on these topics. And I asked those guys, I said, how does AI relate to what we're doing, through all this? And they were, I mean, their answer was almost like I asked a stupid question, and maybe it was, I don't know. But they're friends of mine. But anyway, so the point was, what they said, and I've never forgot this, which is we can model production system behavior with math and simulation, and we already know how to do that. So if you can already do it mathematically and through simulation, whatever, AI doesn't really add you much value. Okay. So then the follow-on question to these guys came, I said, so then how would we use it? And they had some pretty good input. if you're trying to understand your demand in manufacturing, AI could probably assist you. If you're trying to figure out downtimes and where you might have equipment failure, AI will probably assist you. If you're trying to understand standard work processes, right, and this is one that we talked about before, AI will probably assist you. So we have the ability, and have had it for a long time, to model and simulate production systems. Where AI can assist us is with questions about why is the production system perhaps having some kind of anomaly on the demand coming in, right, on the demand forecast, or downtime on machines, right? And so when you have a big chunk of information that you got to understand quickly, I think it can assist with that. And I think where it really can assist in construction, and I can't believe I'm saying this, but when we start talking about mapping production systems and the process flows or workflows that are included in that, majority of people don't actually understand the process of how to do work in construction. It's mind-boggling to me. I'm just blown away, but I guess I'm over it now. So people say to us, "Where do you get the data?" I said, "Get the data to build, put a pipe in a trench. We're going to dig a hole, put in base aggregate, put a pipe in, weld it, test it, and backfill it. Where do you get that information?" But apparently, we need to get that information out, and AI seems to do a very good job at that. So,
Yeah.
good.
Yeah, I think that's where it translates into, not just big capital projects or mega projects, but that translates kind of down the board to smaller projects, data centers, hospitals. I don't care if you're building a restaurant. If you understand your operation and you understand your operational sciences, you know what your crews can do, and you actually have the data that can support that. Yeah, you're definitely going to put yourself ahead of the curve, um, especially in the AI world, which feeds on data. That's why they call them data centers.
Yeah, exactly. I don't. I'm. I mean, this industry never ceases to amaze me, and so we have all this AI at our fingertips now, and guys are using it to optimize the same old shit, right? So AI for RFIs, AI for scheduling, AI for change orders. I mean, I leave it to these guys. I don't understand it. And the construction management, project management, administrative paradigm is so strong, and there's a lot of reasons for that. One is the owners mandate it, and two, there's whole cottage industries built upon it, and people that have careers in it. And I think what we need to figure out where that's going to go. I'll tell you where the big bang is going to be here is on the engineering and design side, right? And so clearly the AI can assist with those kinds of analyses, and so doing again, add on the workflows that we need, um,
Yeah,
and how that's going to occur. But I mean, the procurement process, uh, bid analysis, tendering analysis. I mean, that stuff to me is all going to become automated.
sure.
Uh,
Yeah,
and if you haven't automated that already, I don't know what you're waiting for.
right. And I agree with you there. Obviously, the front end pre-construction work can be done with a more automated level. Obviously, you can't just give it carte blanche, but you definitely can speed up the information that you're getting back a hell of a lot faster. But I think you touch on a good point, which kind of leads us to the kind of the last thing on the lightning round here. Leadership shift. Like you, I'm a huge proponent of guys. We need to track productivity. Productivity. Figure out what your units are and start tracking that. That's kind of, I call it the baseline data. You can't measure the data that you don't have. If you're not collecting that data, how are you ever going to measure it? So let's get that done. But I think what happens is that leadership may be so far removed from that, and that idea. It may be too incremental and it's just not visionary enough, right? But when it comes down to it, and I kind of think about this, executives need to make a change, or at least change their directive to get the folks that are working for them to get focused on what we're talking about here, these units. Let's get focused on what we actually do, what it takes to build it.
Yeah. So this whole field, and remind me to come back to the tribal thing that I've been thinking about. But this whole field of production engineering is missing, right? And we seem to. There's a story I remember when we were working at Heathrow Terminal 5. A guy had a big book of all the standard work, and I said, "What's that?" That's book of standard work. I said, "You use that thing?" He said, "No, we don't do anything." But I hope one day we get back in the business and we actually could use our standard work, right? And so this idea that you'd have catalogs or binders full of how we do work, right, is lost interest amongst most people. As the general contractors in the 70s, 80s became CM firms, they lost that, and especially contractor guys haven't been sophisticated enough to adopt the concept of standard work. But to me, the production engineering creates the standard work. You hear about design for manufacturing assembly or DFMA and the rest. That's a big thing amongst a lot of people. How do we design it to assemble it? And so, DFMA is what we're trying to accomplish, and production engineering is the way to do it. I don't know why we're not deeper into production engineering. That's where the action is. If you want to save time and money, you got to do production engineering and production system optimization, right? And it just doesn't seem to be that much of an interest to people. Now, when people do try to do those things, they're breaking out of what I would call the tribe. Did we talk about this? I don't remember in the last video about the whole tribal thing.
No, we didn't.
Okay.
I think we just touched on it, but I definitely want to hear
Right.
about this because this is
Okay.
very, very interesting.
So my girlfriend and I, Diane, we do a lot of entertaining at the house, and I'm watching people come over that are in the catering business, and I noticed that they do a lot of things that perhaps you wouldn't do it the way you do it, and my I guess I'm a wannabe industrial engineer at the end of the day, or a production engineer guy. I don't know, but I watch these guys. I'm like, wow, that's not really how I do it, but okay. And as I started to work with them, I started to see that there was a very tribal thing going on. Okay. And I'd say, if you were a Somm, you wouldn't do the wine that way, right? Um, there's a there's a set way we do wine. If you're going to make a cocktail, you can get the difference guide out, and they actually tell you the workflow or the steps to make a cocktail. I'm very intrigued with why you guys do what you do. You know, martinis are technically not shaking; they're stirred. Okay, where did you get these ideas that you guys have? And the answer was like the lady with the hand. The lady with
No,
the
it was
hand.
007. 007 said he wanted it shaken, not stirred.
Yeah, and yeah, all right, and someone decided there's vodka in there. So anyways, the list goes on. So it's like the lady with the ham, right? The lady goes to cook a ham, she cuts the ends off, and the husband goes, "Why do you cut the ends off the ham?" And the lady says, "Well, that's the way mom does it." Well, let's call mom and see. She says, "Oh, honey, the pan was too small." All right, so I don't know why they do what they do, but the interesting part isn't why they do what they do, is that they would rather do it wrong and remain in the tribe than do it right. And for someone to say, the way you make a cocktail is you do this, this, and that is counter to how the tribe does it, you're going to be ostracized. You're going to be cut out of the tribe. So I believe what we've created in construction is we had a specialty contractor, amazing contractor in the UK we were with the other day. Amazing, doing incredible work in structural work. Amazing, these bridges, amazing. And the guy said, "Yeah, we use CPM to manage direct hire work, right?" Or as they'd say, works. I'm going, this fucking guy doesn't use CPM for that. None of us would use CPM for that, right? But he wanted to sound important, right? And so what he was trying to say is he's going, "Oh, you guys are probably CPM guys. So I want to say I'm in the tribe too." So
Yeah.
I think that the desire to be accepted in the tribe drives people in construction to do stupid shit that they know is wrong, right? And we celebrate I do CPM rather than do something like production engineering,
Right. It's like
right?
trying to talk the language. You think you're talking the language of the business owner or the GC or whatever. So you're
Right.
talking about CPM so that it sounds like you understand what you're doing.
Well,
Right.
half those fuckers don't know what it is either. The CM, don't kid yourself. They don't fucking know what it is. I mean, I don't know what these people are on their CPM. It's just a word to say I do CPM, right? You ask them what is the definition? They're saying I make a bar chart. Okay, great. So I'm just saying I think the tribal part of this is what's driving this behavior, and I've seen it day in and day out. I see it every day now that this tribal thing has gone on in my head, and I've been talking with some people in the area of neuroscience and sociology and psychology, and actually I did a whole research thing on a bunch of these AI LLMs to come back, and it's a major problem. So I think what the construction industry is suffering from is the ability. We as humans would rather be liked and accepted into the tribe
Right.
than and we'll do something wrong to be accepted. And
Yes,
so it takes a huge set of balls to say, I'm going to do something different.
that is right. Yeah. Even on the superintendent foreman level, They want the attaboy, right? They want to be accepted. They want to, and so we've always done it this way. This is the way we do it. I would, they would even, again, pencil whip something so that it looks good, at least for now, because we want the attaboy. We want to be accepted. We want that. I'm reading this book, Dan Gardner. It's called Risk. And it talks about this very, very specific thing. Even if you know all of the facts, and I'm kind of just in the very beginning of the book, but he was talking about it, even if you know all the facts and you can see that this logically, is the answer. The studies that they've done, they just don't give. I think Daniel Kahneman wrote something about it as well. He did these studies where people would just totally go against the logical grain of what is supposed to be done just because that's the way they feel. That's what they believe. That's part of their tribal, vibe, and it's all about this. Why we do it this way? Well, I don't know. Somebody else, that's just the way we've always done it, or that's just the way it is. It's the only language that we speak here.
Yeah, this whole hours thing is like a mind blower to me. You're going to tell a foreman, you got 2,000 hours to do this piece of work. Okay. Either they're going to get it done for 2,000 or they're not physically. Now, if they can't get it done, they're either going to try to find another cost code to put it to. They're going to start cutting the hours of the workers, right? I mean, there's a lot of that shit that goes on, and right, that people are saying, well, I can't pay you the full amount so you can hit the hours, right? Now, let me ask you a question. Would you rather tell the guy it's 2,000 hours, or would you rather walk out there and say, hey, Joe, we got to get this shit done. What are your thoughts on how to do it, right? Oh, we got to do this and this and this. Do you think we got the right crane? Do you think we got the right forklift? Do you have the equipment you need? What can we do to make this better? Should we do a first run and study it with the guys, right? And then the 2,000 hours becomes 1,000 hours. Now, I don't know, maybe someone's on a T&M job and they want it to be 2,000 hours. I don't know. But this whole idea of telling a guy, here's how much, legally, if it takes 47,000 hours, you still got to pay them. So who gives a shit if there's you follow what I'm saying? It's like, we only got 2,000 hours. Great. But the fucking law says if it takes 47,000, you got to pay the guy. So why waste your time on that and say, shit, we only got 2,000 hours. I better go talk with Joe and figure out and bring out an engineer or whomever else you got to bring out to figure out how we're going to go do this. Right.
And then you get the whole factor of like Parkinson's law, which basically states, if I gave you a week to do something, somehow magically you wouldn't get it done in 3 days. It would actually take a week, even if it really only was 3 days worth of work,
Yeah. And then you're going to get the student syndrome where they're going to wait till the last minute to do it. This whole industry has just got a lot of paradigms that need to change, mostly rooted in things from the turn to the middle of the last century, driven by this tribal nature that I really want to be accepted. So yeah, I do CPM. Yeah, you don't even know what it is, but okay, sounds good.
Right. Well, man, again, I think it's a lot of valid information here. I too believe that we need to be really focused on how we can change the trajectory of how we do things because of the importance of being able to get shit done from now until 2030, 2035, especially when we start talking about, when I say the age of AI, there's some traps in here, Taynor's trap that's in here. We don't have enough power to power this all up. Maybe we don't have enough water. Maybe there's a lot of fights over it. Not to mention just the consistency of these large capital projects not being able to be on time and on budget. And it puts the onus on the public in general to, we're going to have to, bring up enough cash to be able to pay for all that. I don't know about that. It puts us in a very precarious position, especially in the construction industry with these jobs.
Yeah, I would say I'm a little confused, but I just spoke at a conference last week at TechX in London, and my message to them was this, and I'm trying to get like what you're working on. This is what I'm just trying to work on with regard to the digital infrastructure sector. 98% of capital projects at that magnitude have cost and schedule overruns. That's proven. Everybody knows that. And we know what the average overruns are. I believe that the root problem is percent complete accounting coupled with earned value that gives us a false sense of security where we think if we spend 80% of the money, we're 80% done. These tech companies, which were low capital intensive, right? They were doing burn and disk and then downloading software to maybe host some things in the cloud, to now they've moved into where they are now. They're highly capital intensive. And I question how are they having the success they're having? Because I've been out on the sites, I was at one last week, and I'm not seeing anything different than what's been done in those projects that had 98% overruns. So if you're not doing anything different, how do you expect a different result? Okay. And so I'm just sitting back watching, saying, you guys need to be careful, because what we see in large energy type projects and others is at some point you run out of what's called progressible work. And I've sat in meetings where guys are arguing, do we call it non progressible or unprogressible? I'm like, what does it fucking matter? You've spent over 100% of the money, right? So you're at 122% of budget. And they're like, yeah, how do we progress that? And you're saying, yeah, that's the problem. When you think it's going to be $100 and you spend 80, or you think it's going to be $100 and you thought you spent 80 and you're 80% done. But in reality, now you're at $120 and you're really 80% done, right? And I think this is the concern that we need to have. But again, the tribe's not really listening.
Yeah. Well, I get worried on the ground level of things for this, because somebody's going to end up holding the bag on, when the money runs out, because it'll happen. People will get fickle at some point and go, wait a minute, I wasn't planning on spending $200. You know what I mean? Now you're trying to charge me $3. So
yeah, I think that's starting to happen now with at some point, okay, these cost and schedule. So we haven't really been in what we'd call the mega project data center thing yet. We kind of got started a little while ago, right? And we're just now where some of these things should be wrapping up. It would be very interesting to me to see where we are. And the way you see this is you dig into the earnings call, right? And you figure out, okay, let's tie it all together. So remember, there's inbound, there's work in process, and there's finished goods, and then there's over the top, the owner's view. So if we look at guys that are at the AI factory hyperscale level, how much are they consuming NVIDIA, Micron, AMD, et cetera, technology, right? And so if the GPUs are sitting somewhere and they're on the balance sheet of NVIDIA, or they're on the balance sheet of one of the hypers, then we know the project should be delayed, right? So the whip tells us what's going on with the schedule. So all of a sudden we see that the tech's not shipping as it should be, and the tech's not shipping because the facilities aren't being built per the schedule.
that's right.
Right.
That's right.
And that's the way I think we can have a view into what's going on. And so when AWS comes out and says they're going to spend $200 billion this year, which is 4 times more than would be extreme CapEx in the world of oil and gas at the height, right? For anybody, I think Chevron was at 40, maybe at Ramco at 55 or something per annum, whatever the case may be. That placing $200 billion, we're involved in a very large project, civil, basically a nuclear project, and they're trying to get 50 million a month in, right? I mean, it's just really hard to spend that kind of money, right?
Mm-hmm. Yeah. Well, it is going to be a fascinating few years, I think, as we move forward. But for today, man, I really appreciate your time. I really do. Just a wealth of knowledge. I learn something every time I talk to you, and I hope everybody else does as well. Thank you so much. We're going to do another one of these, hopefully next month. But yeah, thank you so much, Todd.
Yeah, thank you, Robert, for having us. It's been very enjoyable and hopefully insightful.
Very good. Well, until next time, folks, thanks for visiting the ConTech Exec. And like I said, we'll be back. And something comes up every week. So you guys check out the podcasts. And until then, everybody be safe out there.